temperature belts on the earth. What are the temperature belts? It means that pressure belts, how the temperature is around the earth, that we will see here. Okay, today we'll see how the effect of the tilt of the axis combines with the spherical shape of the earth to influence distribution of solar heat over the earth. Here the solar heat is distributed throughout the earth by the combination of a spherical shape and the axis which is tilted. This is the axis which is passing from the middle of the earth, connects north pole and south pole. So the axis and the spherical shape of the earth. This is the spherical shape, understand? So the spherical shape of the earth, how these two will distribute solar heat over the earth, we will see instant. We have studied that earlier. Solar rays, when they strike earth's surface, they fall straight in portions which faces directly and fall at an angle as we move away from the portion where it is facing direct. Look at, my dear students, here the sun rays fall vertical directly, right? This is directly the sun rays are falling here and coming to the other area, that is here. It is what to call angle. The sun rays fall diagonally like this instead, right? So there is sun rays falling on the earth's surface is different at a different places. At one place it fall straightly, right? This is the place because here it falls directly, and other area here it falls what to call slantly, that is angle is there, right? Here you can see that is angle. See here the sunrise is falling like this, huh? Here it falls like this instant, that is more, it is not straight line, it is crossing as the rays are going in this way, huh? You see that as the rays going like this, then there is here the portion that is in that portion it is what to call angle is there, right? Some angle is there, that is a spherical because of the spherical shape, understand? And this angle goes on increasing going to the poles, right? Here it is a direct fall of the sun rays, right? When we move from equator to north pole, okay, when we move from equator to north pole, the angle here increases, understand, towards the pole, understand? So as it angle increases, we see that the portion which is facing directly to the sun gets too hotter than the place which is far from the equator, right? Dear students, here it is a place which faces directly to the sun, so it will be very hot. This place will be very hot and sun which is faces directly to the sun. So this is a portion facing directly to the sun, right? Whereas other portion, that is poles, nearby pole, this is not facing directly to the sun, right? So the portion which is far from the sun, this is the portion far from the sun, will experience less hot, okay? Whereas the portion which is facing directly to the sun experiences high hot, understand? So that is the thing. Moving from lower latitudes to higher latitudes, there will be difference in the solar radiation, that is sorry, solar insolation, that is a difference in the insolation we will find, understand. So here, from equator to north pole or to the south pole, we see that there gradually the insolation received by earth is less. So the poles are not much hotter than the equator, understand. So this is the one thing. As the angle of the axis is tilted, then there is a difference in the temperature distribution across the earth, understand. The next, we see that as a result of the tilt of the axis, the area which faces the sun directly keeps shifting throughout the year, right? In the previous class we have discussed. Now at this moment, this is facing to the sunlight directly, right? But earth is not constant, it is rotating and revolving. So while rotating and revolving, the portion of the earth, that means the area of the earth which faces directly to the sun, changes every moment, right? Throughout the year we see the area facing towards the sun keeps on changing, right? So how it is, I'll show in another map here. Dear student, this is a map, a figure you see that. This is figure you see that. On June 21st, right? On June 21st, sun rays fall directly to the Tropic of Cancer. Tropic of Cancer, right? This is the Tropic of Cancer. Here, the sun rays fall vertically. That means this is the area, my dear students. I'll show you that. Yeah, understand? I'm making zoom it. Understand? Look at that. This is the area which gets sun rays directly. It means this is the area facing directly to the sun on June 21st, right? So here it will be very hot as it is exposed to the sunlight, understand. At this moment on June 21st, so on June 21st, dear students, on June 21st, this is the area exposed directly to the sunlight. So in this area it will be hotter on June 21st, because this is the area exposed to the sunlight directly. Okay, when it comes to what to call September, it is September, that is here it is, right, sorry, we will see here December 22nd. On December 22nd, what happened here? The sun rays fall directly on Tropic of Cancer. This is a Tropic of Cancer, dear students. This is a Tropic of Cancer. So on December 22nd, sun rays fall directly on the Tropic of Capricorn. Right? This is Tropic of Capricorn. Just now we have seen on Tropic of Cancer at June 21st. So it was so it is hotter on Tropic of Cancer in June 21, right? And December 22nd, what happened? Sunrise fall vertically directly on the portion of Tropic of Capricorn. So this area is hotter now on December 22nd, right? So every moment there is a change in the area exposed to the sunlight, right? Another you see here, this is March 21st, understand. On March 21st, sun rays fall directly on equator. This is the equator, dear students, understand. So on equator, the sun rays fall vertically. That means This is the area exposed directly to the sunlight. So it becomes very hot on March 21st, right, on equator. Similarly, we see on September 23rd. Okay, this is what to call September 23rd. Again, we see the sun rays fall vertically on equator, right? So at two places, that is March 21st, March 21st, then September 23rd, we see the equator area is exposed to the sunlight directly. Understand? So in this way, the temperature is different in different places. Understand? So here on we see that on June 21st, sun is shining directly over Tropic of Cancer, right? On June 21st. This is June 21st on Tropic of Cancer. This is okay. So there it shines directly. So in the northern hemisphere. Then in the September, we see as the Earth travels further around the sun, we see the sun shines directly over the equator. That is September 23rd. Understand? On September 23rd, sun rays fall directly. Sun shines directly on equator. That is on September 23rd. Understand? Again in December, we see that sun shines over Tropic of Capricorn. Here it is Tropic of Capricorn. Understand? So that it is very clear that this there is a difference in the area of the earth absorbing insolation directly, right? At one moment the temperature, the insolation, sorry, at one moment the insolation is high at Tropic of Cancer, that is June 21, right? And at another moment it is what to call Tropic of Capricorn, that is December 22nd, right? So when this Tropic of Cancer, when Tropic of Cancer, that is 23 and of north latitude, is exposed to the sun directly, then there will be much heat, that is it will be very hot in the northern hemisphere. This is the northern hemisphere, my dear students. Understand? So in northern hemisphere, it is summer, right? As sun shines directly on Tropic of Cancer. So in northern hemisphere, it is summer, and when it is summer in northern hemisphere, it is winter in southern hemisphere, right? One on Tropic of Cancer, sun shines overly on Tropic of Cancer. It is summer. So that time the sun does not shine directly on Tropic of Capricorn here. So it is winter. Okay. When it comes to December 22nd, it becomes reverse, right? What do you see here? Just see this line, dear student, this line. Okay. What do you see on this line? Which is a sun rays. Sun rays fall directly on Tropic of Capricorn. That is 23 and of 22nd. You see this line, sun rays fall directly on Tropic of Capricorn, right? So when it falls on Tropic of Capricorn directly, then here it will be summer. In southern hemisphere, it is summer. Okay, as sun shines directly over on Tropic of Capricorn, that is a southern latitude 23 and off, right? And when it is summer in the southern hemisphere, then it is winter in northern hemisphere, right? That is a thing, understand? And next it is what it is, when it comes to the March 21st and September 23rd, you see that there will be equal day and night at the equator. That also I'll show you. Okay, Look at here, dear students. This is what to call on September 23rd, sun shines directly over equator. Over equator. This is, wait, I'll make it zoom this one. Look at that. This is equator. On September 23rd, directly there falls this equator, right? And in similarly, in March, on March 21st also, on March 21st also, we see that there is sun rays falling on equator. Sun shines directly over the equator. Understand? In that way, we see that there is a change in the absorption of heat by the area which is exposed to the sunshine, right? So it is on March 21st, as the sun rays fall, sun shines directly over the equator. It is spring in the north, spring season, whereas autumn in a southern hemisphere. Okay, on March 21st. When it comes to September 23rd, we see that it becomes reverse. That is spring in the south and not autumn in north. Okay, which is opposite to the what to call is the March 21. Understand? So in this way, there is differences in the seasons. On March 21st and September 23rd, throughout the day, throughout the world, we see that day and night are equal. So that these are called equinoxes. We call them equinoxes. Okay, which one? March 21st, March 21st, this one, and September 23rd. There will be equal day and equal night throughout the what to call earth. Understand? That is 12 hours daytime will be there, 12 hours night time will be there. So equal day and night is observed on September 23rd and March 21st, so that they are called equinoxes. Understand? As we move towards north or south from the tropical belt, we reach what to call, we reach a region where it gets warm in summer but also very cold in winter. Understand? You see here, as we move from equator to north, understand, dear students, when we move from equator to north, then what happens on June 21st on Tropic of Cancer? Sun shines. So it is summer. Understand? When it is summer in northern hemisphere, it is winter. That is southern hemisphere. So in this way, there is a difference, right, in the seasons. When there is summer in a northern hemisphere, at that time it is winter in a southern hemisphere. When it is summer in southern hemisphere, it is winter in northern hemisphere, right? When it is autumn in the northern hemisphere, it is spring in southern hemisphere. When it is spring in the northern hemisphere, it is autumn in the southern hemisphere. The seasons are changing, right? As the seasons change, then we see that pressure belts also changes. Understand? So the northern portion gets snowfall in winter. Understand? That is in December 22nd. On December 22nd, we see it is winter in the northern hemisphere, so it is winter. Understand? As we move further north or south from the temperate belt, so dear students, it is called a temperate belt. Which one from this here you can see that it is equatorial area. It is a tropical belt. Understand? Tropical belt, as sun shines on it. Understand? Only we see that the sun is shining between Tropic of Cancer and Tropic of Capricorn. In these two latitudes, we see sun shines directly, so that it is a area we called tropical belt. What we call tropical belt. Understand, dear students? Okay. Then from 23 under of a Tropic of Cancer in the northern hemisphere to another line that is what to call 66 and of north latitude, that is Arctic Circle, and another 66 and of a circle also we see here. Okay, that what I want to say here. So dear students, look at here, this is what you call 23 and of Tropic of Cancer, and here is that this is 66 and of Arctic Circle, and one more circle will be here, that is 66 and of Antarctic Circle. Okay, so in this area there is what to call angle is there, some angle, the axis is tilted so that the sun rays does not fall vertically. Sun shines somewhat diagonally on this area, so this is the area we call temperate belt. It is what temperate temperate belt, understand, as sun rays does not fall vertically. Okay, between Tropic of Cancer to an Arctic Circle and Tropic of Capricorn to Antarctic Circle, what is a belt we call it is temperate belt, understand. So further moving from this temperate belt, okay, that is at North Pole and South Pole, it is what we call completely there for 6 months. We see that here the sun shine does not vertically on that area. So that 6 months we see it is facing constantly, well, it constantly faces the sun throughout 24 hours of the day, understand. The which area, this is the area, understand, look at here, this North Pole. Okay, here it is a North Pole. This one we see directly exposed to the sunlight, understand, look at here, this one. So this is a this that is the area we see that partly, okay, partial sunlight falls there in the when sun shines on Tropic of Cancer. Okay, so that there will be 24 hours day, and there is no dark night or darkness 24 hours, understand. So a place which has 6 months of day and 6 months of night. That means 6 months we see what to call a night, and another 6 months it is a day at North Pole. Understand? So that as the sun rays does not fall vertically at North Pole and South Pole, there is very cold. So that these are called cold regions. That what we call polar regions, understand, cold polar regions. And so for 6 months it is freezing cold, so it is called what, cold polar region. The Arctic Ocean for 6 months it will be in frozen condition. The soil also here is frozen, it is contracted due to the coldness and becomes very hard, so that no tree grows here, there is no tree cover in the Arctic region. Why does not a tree cover appears in Arctic region? Because the area is covered with snowfall, and that snow which falls there due to the coldness, it becomes very hard. So the soil which becomes very hard does not allow the roots of the tree to grow, so that there the tree does not appear at poles, understand. So we see only when the sun appears for the 6 months, another 6 months, when sun appears for another 6 months, there will be some part melting. So some plants, small plants like mosses, lichen, and some flowering plants only grow here, understand. And another thing here, dear students, the 6 months which is dark in this area, what to call, there won't be completely darkness when sun shines over on Tropic of what to call Capricorn. This is on Tropic of Capricorn here, okay, on December 22nd, the sun shines directly on Tropic of Cancer. So at this time, the sun does not shine directly on the South Pole, right? So at that moment, we see there will be partial light. Partial light means very still light. It is very less light is exposed to the South Pole as it is December 22nd. When it comes to the what to call June 21st, then North Pole is exposed to the sunlight. That is partial sunlight. Understand? So due to that, the regions will appear like this. Look at this figure, my dear students. Understand? This is the figure. What do you see here? How do we get in the morning sunshine and evening sunset? There will be partial twilight. It will be in orange and yellow color, right? So here we see that some greenish yellow color and some other colors due to the what to call there the snowfall and other some what to call the things which are there in the Arctic and Antarctic regions will create this kind of light. There will be partial light for 6 months. Okay, another 6 months we see it is dark, but it's not complete dark. So for 6 months we see this partial light, that what we call aurora australis, aurora borealis. Aurora australis in a southern pole, and aurora what to call borealis in a north pole. Okay, that is partial sunlight we see in the north pole for 6 months, that is called aurora borealis. And another 6 months we see partial light in the southern pole, that is called aurora australis. Understand? In this way we see that there are three pressure belts, the temperature belts. Okay, one is a tropical region, that is between Tropic of Cancer and Tropic of Capricorn, and another from Tropic of Cancer to the Antarctic Arctic Circle, and from Tropic of Capricorn to the Antarctic Circle, that is what you call temperate belt, and at near the poles it is too cold, so that is called polar regions.